Hi everyone, and welcome back to Robotics Unboxed. In this video, I'm going to show you how to create and use custom services in ROS2. We'll go through everything step by step, and we'll also see how to use custom services in both Python and C++. But before we jump into the terminal, let's quickly understand what a custom service is and why you might want to create one. In ROS2, a service is a type of communication where one node sends a request and waits for a response from another node. It's perfect for tasks that are performed occasionally, things like triggering a camera capture, commanding a robot to move to a specific position, or performing calculation on demand are just some of the situations in which you may want to use a service. Custom services allow you to define exactly what kind of data you want to send and receive, both in the request and the response. This gives you full control over how your system behaves and communicates. So, in this tutorial, we'll build a custom service that takes two integers and divides them. It will show us how to handle custom data formats, error handling, and how to integrate everything smoothly in both Python and C++. So let's get started. Let's start by creating a new ROS2 workspace. Open a terminal and create the workspace and source directories using the makedir command. Next, let's move into the new source directory. This is where we'll place our packages, following the ROS2 workspace structure. Next, we'll create a new package to hold our custom service definition. To do that, run ROS2 package create myservices package --build type CMake. This creates a package name myservices package with the build type set to CMake, which is required for defining custom services. Now let's move inside the newly created package directory and create a new folder named srv, which will contain our custom service definition. Then move inside the service folder. Now create a new empty service file using the touch command. The name of the service file will be DivideIntegers.srv. Now open the file in your code editor, for example Visual Studio Code. Inside this file, we'll define our service. In the request part, we want two integers, a dividend and a divisor. In the response part, we want an integer result, a boolean called success, and a string message. Success field is important because it lets the client know if the operation was completed correctly or if something went wrong. For example, if there was a division by 0 or the numbers weren't exactly divisible. The message field provides additional feedback in a human-readable format. This is especially useful for debugging and logging, since you can print or display clear messages about what happened during the service call. Now remember, the three dashes separate the request from the response, and you can use any valid ROS2 message types here. This means you're not limited to integers or string. You can also use more complex types like geometry messages or arrays if your application requires them. This makes custom services very flexible and powerful when designing communication between nodes. Now let's save and close the file. We need to edit the CMakeLists.txt file to tell ROS2 how to generate the service code. So let's open it and, once inside, we need to inform ROS2 to generate code for our custom service. We do this by declaring the dependencies we need. In our case, we need to use the commands find package standard messages required and find package ROS-IDL default generators required. These lines make sure the build system can locate the required packages. Then, we add the ROS-IDL generate interfaces command, which tells ROS2 to generate source code for the DivideIntegers service file. We also specify that this service depends on the standard messages package. This setup is necessary so that the custom service can be compiled and used by other nodes in our workspace. Once all of this is done, we save and close the file. Now, let's open the package.xml file. Here, we need to declare the dependencies that are required to build and run our custom service. This includes the generator used to build the interface code, the standard messages package our service depends on, and the runtime libraries. To do this, we add ROS2 default generators as a build tool dependency, standard messages as a standard dependency, and ROS2 default runtime as an execution dependency. We also have to associate our package to the ROS2 interface packages group using the command member of group ROS2 interface packages. Once you've added these lines, save and close the file. Alright, now we are ready to build the package. First, let's return to the root of our workspace. Once there, we can build everything using call-con-build. Once the build completes, let's check if our service was generated successfully. First, source the workspace to make the new interfaces available. Then, use the command ROS2 interface show myservices package/service/DivideIntegers to inspect the interface definition. You should see the structure of the request and the response we defined earlier. This confirms that the custom service has been correctly built and is ready to be used. Now that we have created and built our custom service, it's time to see how to actually use it in a real ROS2 node. To make this path faster and easier to follow, I have already created two example packages, one in Python and one in C++, and now I'll guide you through their structure and show you how they use the custom service we just defined. We'll start with the Python package called PyCustomService package. This package contains two scripts, PyCustomServer.py, which implements the service server, and PyCustomClient.py, which implements the client. Let's start with the server. First of all, we import the custom service using from myServicePackage.service import DivideIntegers. This gives us access to the custom service definition we created earlier. Then, we define the Python server class and inherit from the standard ROS node. Inside the constructor, we create a service using the createService method. We pass in the type of service, in our case DivideIntegers, the name of the service, which will be divide_integers, and finally the callback function that will handle each request. This setup tells ROS2, whenever a request is received on the DivideInteger service, just call this function to process it. In the callback method, we implement the logic for the division. First, we check if the divisor is 0 or if the division isn't exact. In both of these cases, we return a result of 0. Set success to false and include a descriptive message. If the division is valid and exact, we return the result. Set success to true and provide a confirmation message. Now let's look at the client, which is implemented in PyCustomClient.py. Here, we also define a class, but this time we create a service client object using the method createClient. We then define a timer to periodically trigger service requests. Every 2 seconds, the node generates 2 random integers between 0 and 10, sends the request, and prints the result when it receives the response. The request is sent using the function async send request, which returns a future object, and we attach a callback to it so we can handle the response when it arrives. This approach avoids blocking the node and keeps the logic clear and responsive. That was all for the client and server nodes. Before running any of them though, we need to open the package.xml file and make sure to add an execution dependency on myServices package. Let's now build the Python package only. We do this using the call-con-build command along with the packages select option, which allows us to compile only the package we are interested in. After the build completes, don't forget to source the workspace. Now let's run the server. We'll use the ROS2 run command followed by the package name and the name of the server executable. Next, open a second terminal. After sourcing the workspace again, we launch the client using the same ROS2 run command, but this time with the client executable. If everything is correct, you should see the result printed in the terminal. Now let's use the same service in C++. For this purpose, I created a package called cpp custom service package with two files, cpp custom server.cpp and cpp custom client.cpp. Before moving on, a small remark. In the Python package we just saw, we used a class approach to wrap our server and client within a class. On the contrary, here, we will be using a procedural approach, so without classes. This is to keep things simple and beginner-friendly. As a next step for the more experienced ones between you, I challenge you to create a version of this package using a pure object-oriented approach using classes. Then, show me the code in the comments. Let's now have a look at the two C++ scripts I created for you. Starting with the server, we first include the definition of the custom service using the instruction include myservices package /srv/ DivideIntegers.hpp. Looking at the main, we start by creating a ROS node as usual, and then we define a service object using the method createService. The type of this service will be, as you may expect, DivideIntegers, and we also attach a function to the service server to be called every time another node asks for it. We then simply spin the node to wait for any service request. The logic in the handleService function is very simple and exactly the same as the one used in the Python server. Pay only attention to the types of the arguments of this function. The request is a shared pointer to a DivideIntegers request variable, while the response is a pointer to a DivideIntegers response variable. The request is constant because we are not supposed to modify it, while we have to provide data in the response field. For the client, we again use a simple main function with a loop. After having created a node and a client object, every 2 seconds the node generates 2 random integers, sends the request, waits for the result, and then prints it to the terminal. Please notice that also in this case, we are calling the service asynchronously. This means that the service request is not blocking and we can do other things while we wait for the response. In our case though, we simply wait for the response using the function spin until future complete. And that was all also for the C++ scripts. Let's now see how to properly configure the packages file to correctly compile and build the package. In the CMakeList file, we need to make sure we link against both rcl-cpp and myservices package. To do that, we use the findPackage command to locate these packages, and then we list them in the mn target dependencies call for each executable. This ensures the compiler and linker know where to find the headers and the libraries needed to use our custom service. Finally, in the package.xml, you just need to add a dependency on rcl-cpp and myservices package. Let's now build the C++ package using the callConbuild command. Just like before, we use the packages select option to compile only this specific package. Once the build is complete, we are ready to run the C++ nodes. In the first terminal, source the workspace and launch the server using the ROS2 run command, providing the package and the executable name. Then, in a second terminal, source the workspace again and use the same ROS2 run command format to start the client. As you can see, the client is able to reach out to the server, ask for the service to be executed, and receive the response correctly. This confirms that our nodes work as expected. That's it! We've created a custom service in ROS2 and use it in both Python and C++. We made sure the service handles edge cases like division by 0 or when numbers aren't divisible exactly, and we return appropriate messages. This kind of logic is really useful when building robust, real-world robotic systems. For your reference, I've uploaded all the code shown in this video in a GitHub repository. You can find a link to the repository in the description section of this video. Check it out and feel free to play with it. If you found this tutorial helpful, please give it a thumbs up and consider subscribing to the channel. New exciting videos are coming very soon. Thanks for watching and I'll see you in the next video.